AI model, K-fold cross-validation, K equals 5. Pradeep K. Suri, author, researcher, and AI/ML architect. The point of view you've shared is a K-fold cross-validation, K equals 5, visual explanation, designed for educational or presentation use in AI/ML modeling contexts. It includes mathematical expressions as data points for better visual engagement, and is labeled B. Here's a breakdown of each component and what it represents. Magnifying glass tilted left. What is K-fold cross-validation? K-fold cross-validation is a model validation technique used to assess the performance of machine learning models. It splits the dataset into K subsets, folds, and the model is trained and validated K times, each time using a different fold for validation and the remaining K1 folds for training. In this example, K equals 5, meaning 5 folds. Each row represents one iteration/fold of cross-validation. Brain understanding the point of view layout. White heavy checkmark axis. X-axis represents individual data points, each shown as a famous mathematical formula. Y-axis represents the fold index, 0 to 4, i.e., the cross-validation iteration number. Blue circle color coding. Cyan, small blue diamond training data in that particular fold. Red circle validation data in that particular fold. Each fold shifts the validation data to a different segment of the dataset. Bar chart detailed breakdown of each fold. Each fold, row, contains 10 data points corresponding to 10 formulas. 1E equals MC2, E equals MC2, E equals MC2. 2A2 plus B2 equals C2, A2 plus B2 equals C2, A2 plus B2 equals C2. 3 indefinite integral ABF, x, dx \int underscore A BF, x, dx indefinite integral ABF, x, dx. 4F equals MAF equals MA. 5 sigma I equals 1 n I equals n plus 1. 2 \sum underscore I equals 1 n I equals \frac n plus 1, 2 sigma I equals 1 n I equals 2 n plus 1. 6 equals x \frac d dx x equals x equals x. 7 lim x rightward arrow infinity 1 x equals 0 lim underscore x \to \infinity \frac 1 x equals 0 limx rightward arrow infinity x1 equals 0. 8 sin 2x plus cos 2x equals 1 sin 2x plus cos 2x equals 1 sin 2x plus cos 2x equals 1. 9 log ab equals log a plus log b log ab equals log a plus log blog ab equals log a plus log b. 10 e equals rho epsilon 0 nabla math v equals frac rho var epsilon underscore 0 e equals epsilon 0 rho. In each fold, one of the 5 segments, 2 data points per segment, is selected as validation, red. The other 8 data points are training data, cyan. For example, fold 0 uses data points 1 and 2 for validation. Fold 1 uses data points 3 and 4 for validation. And so on. Direct hit purpose of this visualization. This visual helps convey the fairness of K-fold cross-validation. Every data point is used exactly once as validation. The robustness of this technique, the model is trained and evaluated multiple times on different data subsets. It also visually assures data coverage and systematic rotation of the validation set. Bluebook educational enhancement. Using famous math formulas instead of generic numbers makes the diagram visually engaging and educational, suitable for lectures, presentations, training materials on model evaluation strategies, technologist summary, element explanation. K equals 5 number of cross-validation folds. Color code cyan equals training, red equals validation. X-axis math-based representation of 10 data points. Y-axis fold numbers, 0 to 4. Purpose illustrate data rotation during cross-validation. The point of view you provided, K-fold cross-validation with mathematical expressions, is a model evaluation visualization from the AI/ML domain. This style of informative, symbolic, and structured visualization can be adapted for many other domains to create insightful reports and graphs. Here's a breakdown by domain with potential report/graph types such an point of view style can support. Bar chart 1. AI/ML and data science domain. Model evaluation reports. K-fold cross-validation, like the point of view. Confusion matrix visuals. ROC AUC curve grid across folds. Precision recall per class. Feature importance charts using mathematical annotations. Model comparison reports across multiple ML algorithms. Factory 2. Manufacturing and engineering. Process flow validation reports. Show each fold as a QC cycle across different product units. Component testing reports. Each formula could represent a test parameter, example tensile strength, voltage tolerance. CRA-based performance validation. Each fold represents validation of different CRA milestones. Hospital 3. Healthcare. Clinical trial phase reports. Each fold equals trial phase, data points equals biomarkers or patient metrics. Diagnostic model validation. Use different disease indicators per fold for AI validation. Treatment plan effectiveness. Show fold-wise analysis of treatment success rates. Receipt 4. Finance and accounting. Risk validation reports. Folds equals validation for risk models, example credit, liquidity. Audit cycle reports. Data points equals accounts, folds equals audit cycles. Forecast validation. Compare predicted vs actual values across different fiscal quarters. Test tube 5. Scientific research and R&D. Hypothesis testing reports. Each fold validates a hypothesis or scenario. Experiment reproducibility. Graph per fold equals experimental run with symbolic data points, formulas, constants. Simulation consistency. Visualize simulation consistency across variables or iterations. Office worker 6. Human resources. Employee appraisal validation. Folds equals teams, formulas equals performance criteria. Training effectiveness analysis. Pre- and post-training validation using folds. Attrition modeling. Data folds equals segments of workforce, points equals retention factors. Package 7. Supply chain and logistics. Demand forecast validation. Compare forecast vs actual per product category. Route optimization models. Fold equals model scenario, data equals delivery nodes. Supplier performance review. Fold equals quarter/year, data equals KPIs, timeliness, quality. Books 8. Education and EdTech. Student assessment validation. Fold equals term/semester, data equals assessment components. Curriculum effectiveness. Fold-wise review of each subject/module with symbolic indicators. Predictive model for student success. Similar to AI/ML evaluation. Classical building 9. Government and public policy. Policy impact studies. Fold equals state/region, data points equals policy metrics, health, employment. Pilot program analysis. Fold equals pilot group, points equals impact criteria. Election result forecasting models. Mobile phone 10. IT and software development. Agile sprint reviews. Folds equals sprints, points equals completed features or velocity metrics. Bug classification models. Show model testing over multiple releases. DevOps quality metrics. Fold equals deployment batch, points equals metrics like build success, test pass rate. White heavy checkmark summary table. Domain possible point of view report. AI/ML model validation, feature selection. Manufacturing process validation, QC checkpoints. Healthcare treatment validation, diagnostics modeling. Finance forecast testing, risk assessment. R&D hypothesis validation, simulation outcomes. HR performance appraisal, training effectiveness. Supply chain demand prediction, delivery accuracy. Education student model validation, curriculum effectiveness. Public policy regional impact analysis, pilot evaluation. IT and DevOps sprint analysis, bug prediction testing. AI model, K-fold, random forest. ISO 21001, Educational Organizations Management System, EOMS, focuses on improving the quality and effectiveness of educational services and learner satisfaction. It applies to institutions providing curriculum-based education. You can build several reports and graphs aligned with ISO 21001's requirements and key principles. White heavy checkmark reports and graphs based on ISO 21001, Education Sector. Large blue diamond 1. Learner needs and satisfaction reports. Purpose: ensure educational services meet learner requirements. Reports. Learner feedback summary report. Individual satisfaction scorecard. Learner complaint log and resolutions. Graphs. Bar graph of satisfaction scores per department. Pie chart of complaint categories. Trend line of satisfaction index over semesters. Large blue diamond 2. Stakeholder analysis reports. Purpose: understand the needs and expectations of relevant stakeholders, example parents, regulators, teachers. Reports. Stakeholder engagement report. Stakeholder satisfaction survey analysis. Graphs. Radar chart comparing stakeholder satisfaction. Heat map of engagement frequency per stakeholder group. Large blue diamond 3. Curriculum effectiveness and assessment reports. Purpose: evaluate how well learning outcomes are met. Reports. Course outcome achievement report. Exam pass rate summary. Continuous assessment improvement report. Graphs. Stacked bar chart of pass/fail ratios by course. Line graph of performance trends per subject. Box plot of grade distribution. Large blue diamond 4. Competence and training reports, teachers and staff. Purpose: monitor teacher and staff qualifications, training, and competency. Reports. Faculty training tracker. Competency gap analysis report. Graphs. Progress chart of completed trainings vs plan. Bar chart of competency ratings by faculty role. Large blue diamond 5. Resource management and allocation reports. Purpose: evaluate infrastructure, staffing, and learning material effectiveness. Reports. Infrastructure adequacy report. Learning material usage report. Student-teacher ratio tracker. Graphs. Pie chart of budget utilization per resource. Bar chart of library/resource usage frequency. Large blue diamond 6. Risk and opportunity management reports. Purpose: address risks to education delivery and identify improvement areas. Reports. Risk register report. Opportunity for improvement, OFI, summary. Graphs. Risk heat map, likelihood vs impact. Trend chart of recurring issues. Large blue diamond 7. Internal audit and nonconformity reports. Purpose: ensure compliance with ISO 21001 clauses. Reports. Audit findings summary. Nonconformance register. Corrective action tracking report. Graphs. Donut chart of audit findings by clause. Gantt chart of corrective action progress. Large blue diamond 8. Performance monitoring and review reports. Purpose: track achievement of organizational objectives. Reports. KPI dashboard report, attendance, retention, pass rates. Strategic objective achievement tracker. Graphs. Line graph of retention rates over years. KPI scorecards, using traffic light indicators. Large blue diamond 9. Inclusivity and accessibility reports. Purpose: support accessibility and inclusiveness in education. Reports. Inclusive Education Implementation Report. Special Needs Support Effectiveness. Graphs. Bar chart of special accommodation usage. Trend of enrollment in inclusive programs. Large Blue Diamond 10. Improvement and feedback loop reports. Purpose: drive continuous improvement through feedback analysis. Reports. Corrective/preventive action, CAPA, summary. Feedback response time report. Graphs. Histogram of resolution time for feedback. Trend line of improvements implemented per semester. Pushpin bonus, suggested visual dashboard layout, executive summary. KPI summary, cards or gauges. Satisfaction trends, line graphs. Audit results, pie charts. Risks and CAPAs, heat maps and progress bars. Sample report from K-Fold. Magnifying glass tilted left audit findings summary, ISO 21001, auditor's perspective. The bar chart you've shared presents a visual summary of audit findings across the core clauses of ISO 21001, which is the management system for educational organizations, EOMS. This standard is used to help educational organizations improve their processes and meet the needs of learners and other beneficiaries. Receipt auditor's analysis by clause. Clause findings auditor's observation. Context of the organization: 3 moderate issues found in stakeholder understanding, strategic alignment, or needs analysis. Leadership: 5 several nonconformities indicates weak top management commitment or unclear roles/responsibilities. Planning: too few issues, mostly aligned with risk management and objective setting. Support: 6 highest number of findings likely gaps in resource allocation, infrastructure, competence, or documented information. Operation: 4 some deviations in how learning services are delivered or managed. Performance evaluation: 3 moderate findings typically in monitoring, internal audits, or management reviews. Improvement: 2 minor gaps possibly in corrective actions or continual improvement cycles. Wrench auditor's recommendations. 1 focus area, support, 6 findings. Investigate root causes: are staff trained? Is there a documentation issue? Improve infrastructure and communication mechanisms. 2 leadership, 5 findings. Review leadership engagement, policy communication, and decision making. Conduct top management awareness training. 3 operation, 4 findings. Align actual teaching/delivery processes with documented SOPs. Validate whether learner satisfaction is regularly monitored. Pushpin graph summary, key insights. Bright cyan bars, visually emphasize findings. Dark background, enhances readability and professionalism for presentations. Title: personalization, attributes report to Pradeep K. Suri, author, researcher, and AI/ML architect adds credibility. Blue Book ISO 21001 clause reference, used in graph. 1.4, context of the organization. 2.5, leadership. 3.6, planning. 4.7, support. 5.8, operation. 6.9, performance evaluation. 7.10, improvement. Graduation cap DSS visualization, K-fold cross-validation from an ISO 21001 decision support system, DSS, perspective. This K-fold cross-validation, K=5, diagram provides a powerful metaphor for evaluating decision support systems, DSS, under the framework of ISO 21001, educational organizations management systems. Here's how this visualization aligns with ISO 21001 principles. Magnifying glass tilted left ISO 21001 core principles reflected in the visualization. ISO 21001 principle K-fold cross-validation visualization equivalent. Evidence-based decisions: each fold tests a unique data subset for robust model validation, mirrors evidence-based educational planning. Learner and stakeholder focus: repeated validation ensures no data subset, i.e., no stakeholder voice, is ignored. Process approach: folded structure shows that the model evaluation is a structured, repeatable process. Improvement and feedback loop: each fold provides performance feedback essential for continuous improvement. Data-driven DSS reliability balances bias and variance, critical for making reliable, inclusive decisions. Brain DSS insights derived from the point of view. Repeat button 1. Training vs validation, cyan vs red. Each fold separates training, cyan, and validation, red, data points, similar to how educational DSS must distinguish between data used to develop programs versus data used to validate outcomes. Magnifying glass tilted left 2. Coverage and inclusiveness. Each data point serves as validation exactly once. Ensures fair representation of all learners/stakeholders, a key ISO 21001 value. Bar chart 3. Consistent performance across folds. The uniform structure across all 5 folds simulates stable DSS behavior across scenarios, vital in ensuring that the educational organization's decisions aren't biased by specific cases. Puzzle piece: mathematical equations as symbolic input. The scientific equations, example E equals MC2 F equals Ma equals MC caret 2, F equals Ma equals MC2 F equals Ma, act as data points or knowledge elements. This visualizes a DSS trained on multidisciplinary knowledge to improve curriculum development, resource allocation, strategic planning, compass alignment with ISO 21001 clauses. Clause relevance. 4. Context of the organization. Folding accounts for all learner needs and external/internal context. 6. Planning demonstrates risk mitigation and test planning. 7. Support indicates use of competent methods and data tools. 9. Performance evaluation mirrors internal audits, testing model outputs on unseen data. 10. Improvement. Folding inherently encourages feedback and iterative learning. Receipt. Conclusion: why this is a DSS best practice visualization. This point of view can be used in educational audits or AI-based DSS presentations to demonstrate inclusivity of data, repeatability and reliability, analytical soundness. Embodies ISO 21001's values of transparency, improvement, and learner-centered management.